All right, we're going to move on to measures of variability. And this is used to describe the spread of the data from for a certain variable. And there's basically two ways to look at this. We're going to look at range and standard deviation. Range is very simple. It's the distance between the highest and lowest scores and can usually be reported in one of three ways. The first two are the most common. So we can go from the lowest to the highest score or the highest to the lowest score. So if we're thinking about the scores range from 5 to 15 or from 15 to 5, usually people go with the lowest score first, so 5 to 15. And then the third way to look at it is the difference between the highest and lowest scores. So if we have a range of 5 to 15, we can say the range is 10 overall. Let's look at another example. Let's look at our example of our 5, 7, 8, and 8 staff performance. The range is 5 to 8, or 8 to 5, or it's 3, because the difference between 8 and 5 is 3. So, standard deviation. It measured the spread between each score and the mean point. So we're looking at the average distance overall, the average distance of every score from the mean. And then we can look at what this really means is if there's a standard deviation of 0, it means there's no spread of scores, meaning all the scores are the same number. So let's take this step by step here. We have a set of scores. The first thing we want to do is calculate the mean, which is, remember, adding up all the scores and dividing by the number of cases. Then we want to subtract this mean value from each individual score. So if we have 10 different scores per se, we're going to say the first score minus the mean. What is that? The second score minus the mean. What is that? And so forth all the way across. So we're going to subtract the mean value from each individual score. Then we're going to square each of these deviation scores. So the difference we found for the first one, let's just say it's 3. We're going to square that. So 3 times 3 is 9. Then we're going to add up all these deviation squares. So we'll get a very large number, right? Then we're going to divide that total by n minus 1, where n is the total number of responses. So if we have 10 responses, n minus 1 is 9. So all those squared deviations added together divided by 9, right? And so we're going to come up with a completely new number. Then we're going to take the square root of the answer from that answer. So after we divide by 9, we're going to get a certain number, and we're going to take the square root of that number, and that'll be your standard deviation. And I know it's a lot to think about, but once you get in the habit of really looking at a set of numbers like this, it'll become a little bit more natural and you'll understand it a little bit better. All right, so let's look at another example of standard deviation and help us really understand this. So what we're looking at is a sample of guests who stayed the following number of nights at a resort. So we've got 1, 3, 5, 5, 7, 7, 10. So guest A stayed 1 night, guest 2 stayed 3 nights, and so forth. We want to calculate the standard deviation of this data. So first we want to calculate the mean, if you remember that. So we add up all the nights and we divide by the number of people staying the night. So overall, we're going to add up all the number of nights and then divide by 7. And then we get an average of 5.4 nights stayed per individual. Then we want to calculate the standard deviation. So if you follow along with the column or the chart below, we can look at, for the first guest, we had, he stayed 1 night, and we're going to subtract the average number of nights. So it's 1 night minus 5.4, and we get a negative 4.4. For the second guest, Alan, he stayed 3 nights. And since the average was 5.4, we say 3 minus 5.4 equals negative 2.4. And we do this all down the line. Let's look at Smith, which is the second from the bottom. Smith stayed 7 nights. So we subtract 5.4 nights from that, and we get 1.6, right? So after that, we get all those numbers. So we get negative 4.4 to 4.6. That's the range as well right there so far. And then we're going to square those. So we're going to say 4.4 squared equals 19.4. So 4.4 times 4.4 equals 19.4. And then negative 0.4 times negative 0.4 equals 0.2. So we're going to get a whole range of different answers there, right? So next, after we've got the square of each deviation score, which is our last column of that, we're going to sum up all of those. So we're going to take the 19.4, the 5.8, 0.2, 0.2, 2.6, 2.6, 21.2, and add them all up and we get 52, right? So that's our sum of our squares. Then we're going to divide that by n minus 1. And if you remember, our n is our number of samples, and it was 7. So n minus 1 is 6. So we're going to divide 52 divided by 6 and gets us 8.66. And for this instance, we'll just round up to 8.7 to make it a little easier, right? So we've got, that's the sum of the squares divided by n minus 1. Then we take the square root of our answer from there. So what's the square root of 8.66? Or we round it up to 8.7. What's the square root of 8.7? And that's 2.9. So that gives us our answer. The standard deviation for nights stayed at the resort is 2.9. And then we can interpret that to say the average distance between the individual guest values and the average for the sample size is almost 3 nights. Let's look at another example. Here we're going to calculate the standard deviation for a distribution of the number of visitors over a 5-day period that stopped at a petting zoo exhibit. So on day number 1, we had 1 visitor. Day number 2, 2 visitors. Day number 3, 2 visitors, and so forth. You can see that in the columns there. What we want to do next is calculate the mean. So what we're going to do is we're going to take 1 plus 2 plus 2 plus 3 plus 3 plus 4. So overall, we're going to add up all those scores and then divide by the number of cases, right? So we're going to divide by 6. So 1 plus 2 is 3, plus 2 is 5, plus 3 is 8, plus 3 is 11, plus 4 is 15. So we're going to have 15 divided by 6, right? And overall, we're getting an average of 2.5. Then we're going to go over to the deviation score. We're going to say the first day had 1 visitor. So 1 minus 2.5, remember 2.5 is our mean, is going to end up giving us a negative 1.5. And we're going to do that for every score on that list, right? And then we're going to take each of those scores, so negative 1.5, which is at the top, all the way to 1.5 at the bottom, and we're going to square those. And we're going to get a whole different column of the sum of square, or the squares of the deviations, the square of the deviations. So we're going to take the next step here is we're going to sum all the squared deviation scores from 2.25 to 2.5 all the way to the next 2.25. So we're going to add all those up and we're going to get 5.5. Then we're going to divide that number by n minus 1. And remember, the total number of days is 6, so n minus 1 equals 5. So we're looking at 5.5 divided by 5 equals 1.1. And then if we take the square root of that, we're going to get 1.048. So 1.048 is our standard deviation. We can interpret that by saying the average difference between the visits to the petting zoo each day and the overall average for the entire period is basically 1. So we didn't have the same number of people visiting the petting zoo each day. The mean number of visits per day was 2.5, with some days fewer and other days more to the petting zoo.